Good afternoon. So this is Lab 5 about planning, and let's dive straight into it. So the preliminary questions that I was asked were Strip's representation of an action consists of what two things? And it consists of precondition and effect. So the precondition is or it specifies when the action can be carried out. And the effect is once the action is carried out, what happens to those primitive features that are made true by this action. Then the second part was what is the strip's assumption? And the strip's assumption is that every primitive feature that is not mentioned in the effects is unaffected by the action. Question C was give two example types of constraints used in CSP planning. I picked goal constraints and action constraints. And I'll just quickly explain these two. So an action constraint is basically talking about it constrains what two actions can happen at the same time. It's almost like a mutual exclusion or a mutex constraint. And goal constraint is that it constrains the final state to be a state that satisfies the goals that are to be achieved. And then question D was about what is a horizon in a planning problem. And you can think of horizon as almost like forward checking, something like that. So it is the number of forward planning steps, which include all possible actions and the resultant state. And the implications of choosing a horizon include decision making, complexity, and resource allocation. So let's look at decision making. In decision making, if you're looking at a finite horizon, then you might prioritize short-term gains that are not sustainable or beneficial in the long run. But if you're looking at infinite horizon, then you might value long-term gains. So that is, for example, decision making. And in complexity, if you're looking at a finite horizon, complexity is less. If you're looking at an infinite horizon, of course, complexity becomes more because now you have to start considering the long-term impacts of those actions. And the last part is resource allocation, where in like finite horizons or short small horizons, you're more aggressive by giving out more resources to meet short-term objectives. But if you're looking at infinite horizons or bigger horizons, you might lead to more conservative resource use. Now, question E was after putting all this in the applet, in AI Space applet, what is the starting point and what is the goal? What are the preconditions of go by bike and what are the post conditions of go by bike? So let's just go here and see that here the first thing is what is the starting point? And the starting point is set properties, location. Starting point is home. It was home. And what are the preconditions of go by bike? So preconditions of go by bike is why is this set properties? Preconditions of go by bike is location is home and the have bike property is true. And the post conditions of go by bike are location. So the value is UBC. So those are the post conditions. So that answers this part. And so the starting point is home because starting point is home and the goal is UBC. And yeah, so now we can just solve this using arc consistency. This is the thing that is formed, and then you can just make it look better. And then I can run the auto-solve. And now you can see that our consistency is running, and these domains here, it is true, false. These are going to be checked, and domain and values in the domain that do not satisfy the constraints are going to be removed. So as you can see here, it just changed from true, false to true. Here you can just see false disappeared. And there we go. We found a solution where location is home, have bike is true, have car is true. So this is initial state. And then state one is UBC. Okay, have bike is true and have car is true. And then this shows that you go by bike and you don't go by car. So go by car, state zero is false, and go by bike is true. So in this lab, I learned about CSP. I learned more about CSP and learned a lot about strips representation. Thank you.